Finding possible zeros of polynomial functions. There's really not a lot to say in the rest of these this set of topics, because really it's just going to be what are the possible or potential zeros, how can we find those, and then how can we determine which they are. So this one's going to be talking just about the possible zeros, and then the next couple videos will be how to figure out which ones are the actual zeros. So as a way to get started, I'm going to just talk about a quadratic function for a minute, because hopefully you're very familiar with those, and we can use what we know about this one and make sure that it holds when we talk about how to deal with bigger ones. So here's a quadratic function, and you should already have in your mind all kinds of things you could say about it. If I write it in factored form or intercept form, hopefully you can get that one almost that fast, then I know that my zeros are 5 and -2. So we know that because we know other facts about it, we know it opens up, we know that it's got kind of the standard arrangement, and we know that it crosses the x-axis at 5 and -2, and we could, do a rough sketch of it. But now we want to be able to say not just a quadratic, not just one that is factorable. What about any polynomial function? So we're going to talk about polynomial functions with integer coefficients. So positive and negative whole numbers, not talking about fractions, not talking about any other kind of number, just integer coefficients. If we have that kind of thing, then our rational zeros are going to be, because we could have, complex solutions, complex answers, but it's going to be the factor of the constant divided by a factor of the leading coefficient. Now, I told you that we've been talking a lot about the leading coefficient's sign, and I told you eventually we're going to need to know the number of the leading coefficient. And they tend to talk about this as, and we're going to take the positive and negative versions, so plus or minus p over q. Not that critical that you know that, but if you see it, if you look in the book, that's what you're going to see. If you look at it in any other kind of text, that's what it's going to be. So what that means is if I took our quadratic function that we've already talked about, and when I say rational zeros, very important, I'm going to sneak a word back in there. These are the possible rational zeros, right? So it's not that all of those things are going to work, but to find the possible rational zeros, if I look at my previous function I talked about, our constant is 10, so the factors are 1, 2, 5, and 10, and the leading coefficient is 1. So our possible zeros of that function would be positive and negative. Now, since we have a leading coefficient of 1, these are all going to be integers. We don't have to go through various denominators. So it would be 1 over 1, 2 over 1, 5 over 1, and 10 over 1. So the possible zeros of that function were positive 1, negative 1, positive 2, negative 2, positive 5, negative 5, positive 10, negative 10. Well, this one, it was just so easy. We just factored it and we found the exact zero. So we don't need to know that about a quadratic. If we can easily factor it, we're going to find the integer roots and sometimes some fractional roots. But when we get to bigger functions, we don't want to go through all the work of factoring them or go through the work of dividing them if we don't have to. Sometimes it's going to be easier to just kind of check from a short list. Now we'll look at a larger polynomial function. Again, we could be asked to do lots and lots of things with this. Our question's going to be this time, what are the possible zeros? And so we're going to write down what our constant is. Our constant is 15. So the factors of the constant are 1, 3, 5, and 15. And our leading coefficient, thankfully, is 1. So there's only factor is 1. So our possible zeros of that function are positive and negative 1, positive and negative 3, positive and negative 5, positive and negative 15. So if the leading coefficient is 1, it's a very short list. It's just the factors of the constant. We love that. However, what if we have a function that doesn't have a leading coefficient of 1? Here we've got still have a cubic function. So what makes us more work isn't the fact that it's a higher degree. What makes us more work is the fact that our leading coefficient isn't 1. So if we go through the factors, or what our constant is, our constant is 6. So the factors are 1, 2, 3, and 6. So we're going to have to check all those. But this time our leading coefficient isn't 1, it's 2. So the factors of 2 are 1 and 2. So we're going to have to check all of the top numbers over all of the bottom numbers. So we're going to have, and make sure you have some kind of methodology. I'm going to go through the ones with 1 on the bottom. This isn't a fraction. This is I'm kind of getting my setup here. And I wouldn't do this on a regular basis. I just kind of want to give you a heads up of what I'm going to do. I'm going to go through all the things with a 1 on the bottom, and then I'm going to go through all the other things with a 2 on the bottom. So it would be positive or negative 1, again, over 1, positive and negative 2 over 1, positive and negative 3 over 1, positive and negative 6 over 1. And I didn't put the 1s before because we know they were going to be 1s. So what that yield so far is 1, 2, 3, and 6. But we also have to try all those numbers over 2. 1, 2, 3, and 6. 6 all over 2. Well, this is just 1. So we already have that covered. This is just 2, so we already have that covered. So the only thing we have to add to our list is positive and negative 1/2 and positive and negative 3/2. So this time we have lots of potential zeros, or possible zeros. We have 2, 4, 6, 8, 10, 12 potential zeros, right? So once you have a denominator, it just keeps increasing how much work you have to go through to get the list. Make sure you get rid of your ones that are already taken care of by, simplification. So to find the possible zeros, not a whole lot of work as long as you know your factors of things pretty well. Just factors of the constant over factors of the leading coefficient. Don't forget to simplify the fraction ones.